Good morning all. Now in today's class I will explain some concepts of multi-threading. Last class I started multi-threading and explained the basics of multi-threading. Okay. Now we will continue the previous class. Now coming to multi-threading, it is there in your 4th unit. The entire 4th unit is only on multi-threading, but that's why try to learn more concepts on multi-threading, and it is also heart of Java. So multi-threading is very concept in Java. When you go to interviews, they will ask questions on multi-threading and exception handling. That's why I am taking many classes on exception handling and multi-threading, because these two concepts are very important. Not only for exam, for interview point of view also, multi-threading is very important. It is heart of Java. Okay. Now coming to the multi-threading, here we have introduction, ways to define, instantiate and start a new thread. So here this is very important concept. How do we define a new thread and how do we instantiation is nothing but initialization. Okay, and start a thread. So how do we define a thread? Last class I explained, no? Okay, for each thread you have to take one separate class. That class may extend either thread class or that class may implement runnable interface. Because I already explained there are two ways to write multi-threaded programs. Okay, to define a thread, there are two ways. So thread definition is nothing but class definition only. Thread is nothing but a class. Okay, don't think otherwise. Thread is nothing but a class. But which classes we can use to write a thread is that class must extend either thread class or that class must implement runnable interface. So how do we know whether that class is for a thread or not? That is the first important question to remember. So how do we create a new thread in multi-threading programs? So creation of a new thread is nothing but creating a new class. But if you take normal classes like class test, class student, they are not behaving as threads. Why? Because when we say the given class is behaving like a thread, is okay, that class may extend either thread class or that class may implement runnable interface. So you know thread is a predefined class which is there in java.lang package, and runnable is a predefined interface which is there in the java.lang package. That's why in multi-threading, please focus on predefined class thread and predefined interface runnable. So if you want to write the programs on multi-threading, so our focus must be on thread class and runnable interface. If you understand the thread class and runnable interface, then you can write any number of programs on multi-threading. So here thread is a predefined class and runnable is a predefined interface, and both these are there in java.lang package. That's why to write multi-threading programs, no need to import any other package, because already we have default package which is available for each and every program in Java. That is import java.lang.star. Whether you write or not, this statement must be available for each program in Java. What is that default statement? Import java.lang.star. Okay, this is the default package which is available for all the programs in Java. As I already explained, thread class and runnable interface both are there in the package java.lang. That's why no need to write any import statement explicitly when you want to write multi-threading programs, because in each and every multi-threading program we are using either thread class or runnable interface, and these two are there in java.lang package. That's why no need to write any import statement explicitly. Directly we can use thread class if you want, or directly you can use runnable interface if you want. Because in multi-threading programs, we are using only thread class and runnable interface. Okay, that's why please concentrate on thread class and runnable interface. Okay. Now second one is ways to define. How to define a new thread is nothing but how do we create a class which extends either thread class or runnable interface. A class which extends thread class or a class which implements runnable interface. So in these two cases, these two classes are behaving like threads. That's why a class which extends thread class or a class which implements runnable interface. Okay, in these two cases, these two classes are behaving like threads. So thread is nothing but a class. But what is the rule for that class is that class must extend either thread class or that class must implement runnable interface. Then only that class is behaved like thread. So creation of a new thread is nothing but creation of a class. Class is having definition, no? That's why define a new thread is nothing but writing a class definition. But writing the class is not a thread. But when that class is behaving like a thread is either that class may implement runnable interface or that class extends thread class. Only in these two ways we can create a new thread or we can define a new thread. Next, instantiation is nothing but initialization. Initialization means you know how do we create object. Okay, this is nothing but creation of object is nothing but instantiation of a new thread. Next, start a new thread means you know already explained last class after creation of an object. Okay, for the child class which extends thread class, we are using t1.start now. Okay, so after creating an object for the child class which extends thread class, so we have to invoke the start method of the thread class by using t1.start. Okay, when you write t1.start, okay, it goes to the start method of the thread class. Okay, start method of the thread class is very, very important. Okay, start method of the thread class is heart of the multi-threaded programs. So try to understand these three concepts. How do we define a new thread? How do we instantiate a new thread? And how do we start a new thread? If you understand these three concepts, we can write any number of programs on multi-threading. First, define a thread by taking one class which may extend either thread class or which may implement runnable interface. After writing the or after defining the new thread with class, so you have to create the object for that class. Next, with that object, invoke the start method of the thread class. Okay, these three are very, very important. Okay. Next, getting and setting name of a thread. Each and every thread has unique name. I will explain with one program how do we set and get name of a thread. Next concept is this is getting and setting name of a thread. First, write the simple programs using define, instantiate, and start a new thread. After understanding the basic programs using these three concepts, then you can go for this program. This program is nothing but getting and setting name of a thread because each and every name has a unique name. That name can be either default name or our user defined name. Okay, I will explain this concept. Okay, next coming to thread priorities, because all our threads are registered with the thread scheduler. No, means all our threads are in the waiting queue. So in multi-threaded programs, we can create any number of threads. Last class, we have seen a program. How do we create two threads? That is my thread and main. Main is always a thread in any program. Okay. So in addition to the main, we have created one more thread that is my thread. Means in the last class, we have seen one program where we have two threads, minimum two threads. Okay, maximum can be any number of threads. So coming to this concept thread priorities. So each and every thread has one priority. Okay, default priority of a thread is 5. And thread priorities are in between 1 to 10. Okay, now how do we set and get priorities of a thread? We will see in thread priorities. Next concept is the methods to prevent a thread from execution. Okay, now I will explain this the concept of life cycle of a thread. Then you can understand there in that with that the life cycle of a thread you can understand the concept more clearly. First, try to understand the basics. Don't by heart the multi-threaded programs. If you by heart, there is no use of studying Java. Try to understand each and every line in multi-threading programs. The next, this is the methods to prevent a thread from execution. Suppose if a thread is having the CPU, our thread scheduler allocates the CPU for one particular thread. Okay, now these are the three methods. Okay, using these three methods, we can prevent a thread from execution. Means a thread which is having the CPU, that thread can be prevented from execution using these three methods: yield, join, and sleep. Next concept is synchronization. Next is inter-thread communication. Next is deadlocks. Then daemon threads. Okay, these are the important concepts in Java. Okay, see again. Introduction, ways to define, instantiate, start a new thread, getting and setting name of a thread. Next, thread priorities. Next, the methods to prevent a thread from execution. They are yield, join, and sleep methods. Then synchronization. This is also very, very important concept. Next, inter-thread communication. Next, deadlocks. Next, daemon threads. So these are the important concepts in multi-threading. Okay, we will see one by one. Already explained the one program on multi-threading in the last class. That is, how do we define a thread, how do we instantiate a thread, and how do we start a thread. This concept again we will revise once with the last class program. Then you can understand more clearly. What is the last class program? Now this is very, very important. Okay, the ways to define a thread. So how to define a thread? Already explained. Define, instantiate, and start a thread. These are the three concepts which are very, very important in multi-threading programs. How do we define a thread? How do we instantiate a thread? And how do we start a thread? So define, instantiate, and start. Okay, now in this program I will explain these three concepts. Now coming to the define a thread or defining a thread. Okay, first one is define, second one is instantiate, third one is start. First one is defining a thread. No, so how do we define a thread? Is there are two ways to define a thread. Already explained. Repeatedly I am telling this one. This is very, very important to write multi-threaded programs. Unless you understand this concept, you can't write even single program in multi-threading. That's why how do we define, how do we instantiate, and how do we start a thread? Try to understand. Okay. Now the ways to define a thread. So we can define a thread in the following two ways. What are the two ways? By extending thread class or by implementing runnable interface. Already in the last class I explained a program on this. That is extending thread class. Okay. And now I will explain in the same program what are these three concepts. Okay, how do we define a thread, how do we instantiate a thread, and how do we start a thread. So in this program I will show you all these three concepts. But only defining a thread is, for defining a thread there are two ways. Okay, they are by extending thread class or by implementing runnable interface. Now I will show you in this program, that is by extending thread class, okay, where we have defined the thread and where we have instantiated the thread and where we have started the thread. I will show you, I will explain these three concepts more clearly with respect to this program. This is the first program is nothing but how do we define a new thread by extending thread class. Now in this program already last class I explained. So class myThread, it is not a normal class. So if the class myThread extends thread means we will consider this as a thread. Okay, this is the definition of a thread. See, already explained, defining a thread. So defining a thread is nothing but this part. This is like normal class only, but normal class means we will write only class myThread. That's it. But here we are writing, we are creating or we are defining a new thread. So how do we define a new thread? This is the very important point. Okay, if a class which extends thread class is nothing but defining a new thread. That's it. Okay, class which extends thread or which implements, in place of extends thread, I can take implements runnable. In place of extends thread, I can take implements runnable. So class my thread extends thread or class my thread implements runnable means it is a thread. Means we are defining a new thread. So how do we define a new thread? Is a class may extend thread class or a class may implement runnable interface. That's why this is the definition of a new thread. Okay, this is the first part. Here we have three parts now. Any multi-threaded programs. How do we define a new thread? How do we start? How do we instantiate a new thread? And how do we start a new thread? So this is the first part. That is how do we define a thread. So class my thread extends thread. This is open brace of that class. This is the closing brace of that. So from this part to this part is nothing but creation or defining a new thread. Okay. So always whenever you define a new thread, inside that thread write only the overriding run method of the thread class. When you take extends thread, because of inheritance, already that thread class contains run method which is having null implementation. So this is the child class of thread class. Already thread class is having the run method with null implementation. So whenever you define a new thread, compulsory we must override the run method of the thread class. So this run method is called overriding run method. Because in the thread class, that is in the super class, already we have run method with null implementation. In the child class also we are writing the same run method but with different functionality. That's why this is called overriding run method. So whenever you define a new thread, compulsory we must override the run method of the thread class. This is one more important point to remember. So okay, so inside the run method, what we are writing is, we are writing the functionality of this thread inside this overriding run method. So this overriding run method purpose is to write the job of the thread or to write the functionality of the thread. That's why here this for loop is for writing the functionality of the thread. So why we should override run method is, inside the overriding run method only we will write the functionality of the thread. So where we write the functionality of the thread in multi-threaded programs, the answer is inside the overriding run method we will write the functionality of the thread. So this is called defining a new thread. First define a new thread either using extends thread class or implements runnable interface. After that, inside that class always we must override the run method of the thread class when you write extends thread. Okay, so inside the overriding run method, I will write the functionality of that thread. Okay, so functionality of that particular thread is written inside the overriding run method. So understand, if you understand this, you can write any number of multi-threaded programs. Next, what is another thread? Okay, main is one more thread. So take separate class and write the main method as usual. Now here I will explain. Is it instantiation of a thread? Okay, so in thread we have three concepts. Start this one. First one is define a thread. So already we have defined a thread. So this entire part is nothing but defining a new thread. So what is the second concept is? Second concept is instantiation of a thread. Instantiation of a thread is nothing but creating an object for that thread. So here what is the thread? This is my thread. Okay, the name of the class is my thread. If you create a class, we can create any number of objects for that class now. So for this class, I will create an object. So creation of an object for this class is nothing but instantiation of the thread. So how do we instantiate a thread is this one. So creation of an object for that my thread class is nothing but instantiation of a thread. So this is the second one. So this is instantiation of a thread. See here I have written instantiation. So how do we create an object for my thread class? So this is my class name is my thread, no? So this is the class definition. For that class, I am creating an object like student class. We have created so many objects, no? Student S1 is equal to new student, student S2 is equal to new student. Like that, once we define a my thread class, okay, for creating a new thread, we can create any number of objects for that class. So this creation of an object for my thread class is nothing but instantiation of a thread. So second is completed. What is the third one? Three important points to remember. That is, first one is define a thread. Second one is instantiate the thread. Third one is start the thread. So this is the second one. Okay, instantiation of a thread. Third one is start the thread. So how do we start the thread? So starting the thread is nothing but invoking the start method of the thread class. So with this object, that is with this reference variable t, I will invoke the start method of the thread class. That is nothing but starting a new thread. So defining, instantiating, and starting a new thread. So if you understand these three steps, then you can write the multi-threaded programs on your own. Okay. So what is this? What is the meaning of this t dot start? Already explained in the last class. Whenever you write the t dot start method, it goes to the start method of the class. So inside the thread class, predefined thread class, we have two methods, start method and run method. So what is the purpose of start method of the thread class is, first it will register our thread, means it will register our new thread. Because here we have defined the new thread or we have created the new thread now. So this thread will be registered with the thread scheduler using the start method of the run thread class. That's why always we must invoke the start method of the thread class with this reference variable. That's why t dot start will invoke the start method of the run the thread class. So inside the thread class we have two methods, important methods. They are start method and run method. Already explained, run method is having null implementation. But whereas inside the start method of the thread class, we have two functionalities. They are first, the start method of the thread class will register our new thread. Okay, will register our new thread with the thread scheduler. After that, it will invoke the run method of the same class. Okay, so run method of the thread class is having null implementation. That's why we must override the run method of the thread class in the child class. That's why it is called overriding run method. Okay, so these three steps are very, very important. How do we define a thread? This is the concept of defining a new thread. After that, how do we instantiate a new thread? This is second concept. And third concept is how do we start a new thread? So how do we start a new thread is using t dot start. T dot start means it will invoke the start method of the thread class. Inside that our new thread means this is our new thread. No? This thread is registered with the thread scheduler. After that it will invoke the run method of the same class. Next, so these three are completed. Next, after this statement, that is t dot start statement, here we have two threads. Suppose before this statement, we will see. So before t dot start, how many threads are there? So before this statement, t dot start, our thread is not registered with the thread scheduler. No, only whenever you invoke the start method of the thread class, then only a new thread is created. Okay. So before this statement, that is t dot start statement, only one thread is there, that is main. But after the t dot start statement, we have two threads. They are main thread and this is the another thread. No, this is my thread is another thread. No, now here we have two threads. They are main and this my thread. So after t dot start method only, okay, we have two threads. Before t dot start statement, we have only one thread, that is main method. So creation of an object is nothing but creation of an object means don't think that our thread is registered with the thread scheduler. We are simply created an object. That's it. That's why after this statement also there is only one thread. that is main thread. But whenever you write T dot start, this is the heart of multi-threaded programs. So T dot start statement is the heart of multi-threaded programs. So whenever you write T dot start, then only new thread is created. Okay, and our thread is registered with the thread scheduler. That is very, very important. Otherwise, not if you write simply this is the thread definition. No? So with this, no new thread is created. Only we are simply writing the definition of a new thread. But when you are when the actual or actually the new thread is created and it is registered with the thread scheduler is using this T dot start statement. So this statement is very, very important. If you understand these three, how do we define, how do we instantiate, and how do we create a new, how do we start a new thread? So then you can write any number of multi-threaded programs. So after this T dot start, we have two threads. They are main and child threads. Main thread is this main, means this is the functionality of main. No? This is the definition of main thread. Now onwards to call it as main thread. So we have to define a thread, no? So this is the functionality of main thread, and this is the means this is the functionality of, this is the definition of main thread, and this is the functionality of main thread, and this is the functionality of the child thread. So when you execute this program, okay, so JVM will invoke the main method. After that, an object is created for the myThread class. After that, we are writing T dot start. Means our thread is registered with the thread scheduler. Means now new thread is created. Now here after this statement, we have two threads, that is main thread and child thread. This is the functionality of the main thread, and this is the functionality of child thread. So whenever you execute this program, first JVM will invoke the main method, then this object is created. After that, we have written T dot start, means a new thread is created for the child thread. Okay, then after that we have two threads, main thread and child thread. Next, then we don't know, because our new thread is registered with the thread scheduler. So now after this statement T dot start, we have a waiting queue with two threads, that is main thread and child thread. Okay, child thread name is myThread. So now here it is based on the CPU scheduler. So which thread is allocated CPU by the thread scheduler out of these two threads, that is main and child, we don't know. Okay, that's why this is, even though here we have written the functionality for main thread, first it will not be executed completely, because from this after this statement we have two threads which are registered with the thread scheduler. So if the thread scheduler allocates the main method for the main method, the CPU, then this will be executed. Or if the thread scheduler allocates the CPU for child thread, then which part will be executed? This for loop will be executed. That's why we don't know. That's why in multi-threaded programs we can't guess the output. So but we can write only possible outputs. So these are the possible outputs. So please execute this program. Next, here I'll already explained. So only two important points to remember in multi-threading is, you can notes is there clearly. You can write what is the difference between T dot start and T dot run. Okay, all the cases are there. Please study on your own. You can easily understand once you understand the start method and run method of thread class. Next, one more important point is regarding T dot start and T dot run. So already in thread class, I will explain here. See here, this is the importance of thread class start method. So inside the thread class, we have inside the thread class, here I have written. So inside the thread class, we have two methods. They are start method and run method. So what is the purpose of start method of the thread class is register our thread with the thread scheduler and invoke the run method. Next, inside the thread class, we have one more method, that is run method. The syntax of run method is last class I have shown you, that is public void run with null implementation. So if from the start method or inside the start method, run method is invoked. We can't invoke directly. So run method of the thread class is invoked from the start method of the thread class. So what is the role of the start method of the thread class is register our thread with the thread scheduler and it also invokes the run method of the same class, that is thread class. It is having null implementation. So regarding start method and run method of the thread class, now I will explain 2 points. Okay, please try to follow these 2 points. If you understand these 2 points, enough for multi-threaded programs. So here always, okay, we must override the run method of the thread class in our thread definition. Okay, so overriding of the run method of the thread class is must in our thread definition. Next, one more point is, don't override the start method of the thread class. If you override the start method of the thread class in your thread definition, this start method of the thread class will not be executed. You know the inheritance rules, no? If child class is first child class object will give the first priority to its own class members only. If they are not there, then only it will take from the super class members. Because in the programs we are creating the objects for child class. See in the last program. If you see this program, for which class we are creating object, here my thread is called subclass and thread is called superclass. Inside the thread class, we have 2 important methods. They are start method and run method. Okay, start method, okay, is having the is doing 2 functionalities. First, it is registering our new thread with the thread scheduler, and it invokes the run method of the thread class. So that is the role of start method of the predefined thread class. And what is the role of the run method of the thread class is, there is nothing. Only it is having null implementation. That's why here 2 important points to remember. So always, okay, it is must. Always the run method of the thread class must be overridden in the child class, that is in my thread class. So overriding run method is must in all the threads. Okay, in all the threads, we must override the run method of the thread class. That is the second important point. First important point is, don't override the start method of the thread class in the child class. Suppose if you override the start method of the thread class in this my thread class, what will happen is, when you write t dot start, because we have created object for the subclass, not for the superclass. So always subclass will give the priority to its own members only. Suppose if you override the start method of the thread class in my thread, that is in the subclass, then what will happen when you write t dot start is, it will execute your overriding start method. If you override the start method in the subclass, okay, with the execution of t dot start, it will execute your overriding start method. If you override the start method in the subclass with t dot start, it will execute your overriding start method. But when it executes this overriding start method, what is the drawback is, no new thread is created. Only with the start method of the thread class, a new thread is created and it is registered with the thread scheduler. Unless you register your new thread with the thread scheduler, it is not a multi-threaded program. So if you override start method of the thread class in your class, that is my thread, what will happen is, when you write t dot start, it will not go to the start method of the thread class. Simply it will execute your overriding start method. So it is like normal call to the start method. In this case, you are having only one thread, that is main thread only. So that is the drawback of, then this program comes under what? Single threaded programs. So if you override the start method of the thread class in the thread definition, then it is a single threaded program. So it is not a multi-threaded program. So multi-threaded program means always we have to invoke the start method of the thread class. That's why start method of the thread class is playing very, very important role. It is like heart of the multi-threaded programs. Unless you invoke the start method of the thread class, no new thread is created. It is like normal call to the start method. That's why two important points to remember in case of multi-threaded programs is, first one is, okay, don't override the start method of the thread class. Okay. Second important point is, always we must override the run method of the thread class. If you remember these 2 points and if you understand the meaning of these 2 points, then you can easily understand the multi-threaded programs. Again, I am repeating, don't override the start method of the thread class in the thread definition. Second, we must always override the run method of the thread class in your thread. This is the thread definition. No? Okay. So whenever you override the start method of the thread class in your thread definition, then it is like a single threaded program only. It is not a multi-threaded program when you override the start method of the thread class in the thread definition. That's why again I am repeating, don't override the start method of the thread class in your thread definition. And second one is, always we must override the run method of the thread class in your thread definition. So with these 2 points, you can understand the multi-threaded programs more clearly. Okay, these 2 are very, very important points. Okay, now after this, what we will do is, here we have cases now. Now I already explained, so you can follow easily on your own all these cases. Okay, so importance of, this is importance of thread class start method. Next, case 4 is overloading of run method. We can overload the run method, no problem in that. So here I have written, overloading means run with no parameters, run with one integer parameter. But this is here inside the, see, follow carefully. When you overload the run method in your thread definition, okay, always write the job of the functionality inside the run method with no parameters only. Because inside the thread class we have run method with no parameters, we are overriding the run method of the thread class in our thread definition. Inside this run method only we will write the functionality of the thread. Don't write the functionality of the thread here. It is like normal run method. Means here, and one more difference between these 2 is, this run method need not be invoked explicitly. We need not write t.run. Why? Because this overriding run method is invoked as part of the start method of the thread class. Because inside the start method of the thread class, first step is our new thread is registered with the thread scheduler and it invokes the run method. That's why this overriding run method need not be invoked explicitly. Okay, as part of the start method of the thread class, this run method is invoked. But if you take, this is overloading run method, but this is like a normal method. So here we must invoke this run method with one integer parameter explicitly. So don't write t dot start, we have written in the previous program, no? So t dot start correct only, but don't write t dot run. T dot run means it will go to this one. It is like normal function call. Okay, so that's why write only t dot start. So through this start method of the thread class, we are invoking the overriding run method with no parameters. This is the overriding run method of the thread class, and here we are writing the functionality or job of the thread. That's it. This is the very, very important run method. But if you take the overloading run method, it is like normal function call. That's why we have to invoke this explicitly. But this need not be invoked explicitly as part of the start method of the thread class. This is invoked automatically. Here I have written like that. Here for if we are not overriding run method, so we must overriding the run method. No. Suppose if you want to override the run method of the thread class, what will happen is it will execute the run method of the thread class. Run method of the thread class is having null implementation. No. So here again, when you write t dot start, when you write t dot start, it will invoke the start method of the thread class. Again, inside the start method of the thread class, we are invoking the run method. Suppose if you want to override the run method of the thread class, so from the start method of the thread class, it will go to the run method of the thread class. What is there in the run method of the thread class? Null implementation, no? That's why nothing will happen. When you want to write the job of the functionality of the thread, always we must override the run method of the thread class. If you want to override the run method of the thread class, simply nothing will happen. Means functionality is not there for that thread. But why we are writing multi-threaded programs? To write one functionality in each thread, no. Best example for multi-threading is, I will explain like this. Suppose we have to calculate sum of two numbers, product of two numbers, division of two numbers, and modulus of two numbers. Okay, like that we have 4 or 5 arithmetic operator, no? So for each of these arithmetic operator, take each arithmetic operator and take, suppose your program is like this. Okay, find the sum of two numbers and product of two numbers and this division of two numbers and modulus of two numbers. Suppose if this is our subtraction of two numbers, I have 5 tasks to do in the same program. See, here we have 5 tasks. I have to add two numbers, multiply two numbers, divide two numbers, subtract two numbers, and modulus of two numbers. Here I have to do these 5 tasks. Now, if you want to write multi-threaded program, performance-wise, is it good? Or if you write single-threaded program, is it good performance-wise? Always performance-wise, multi-threaded programs are very, very important. Why? Because here all the threads are executing parallelly, not one after the other. In single-threaded program, if you write the same program for sum of two numbers, addition of two, this multiplication of two numbers by taking different functions. In single-threaded program, first if you invoke t1.sum, sum will be executed and that will sum will be invoked and it will be executed completely. After that only we will write t1.product. Means the product function is invoked and the product is calculated for the two numbers, and after completion of that product only we have to invoke which one next? Division. Like that, if you write 5 functions, separate functions only, even though if you write separate functions in multi-threaded programs, so we have to invoke first t.sum, next t.product, next t.division, like that we have to invoke all these functions. What is the drawback of that program is, even though if you take 5 functions, so first sum function has to be completed first. After that only it will go to product function and it will complete the product function. Then division, like that it will execute each and every function one after the other only. That is the concept of single threaded program. In that the thread is main. Main is the only one thread. Okay, if you calculate all these, if you do all these 5 tasks, okay, but that is single threaded program. There only one method, one thread, that is main thread, but we have written 5 separate functions for each task. That is the concept of function. That is the advantage of function. Instead of writing all the 5 tasks in only one function, that is main function, what we are writing is we are using functions. That is the advantage of functions only, correct only. But that is a single threaded program. Even though if you write 5 functions, one function for each task, but that comes under only single threaded program. Why? Because main is the only one thread in that program. So performance wise, even though if you take functions, performance wise it is not at all good. Whenever it is possible to write multi-threaded programs, always better to write multi-threaded programs only. Now for the same task, I will write multi-threading program for the same task. Okay, means for the same concept. What is my concept there? I have to find sum, product, division, modulus, and subtraction of 2 integers. Let us take that is my concept. So for that same concept, I can write the program 2 ways. First, I will write a single threaded program using main thread, and I will use 5 functions. Okay, next I will write this, I will take the same concept, I will write multi-threaded program for that concept. So how do we write multi-threaded program for that concept is, how do we write? First definition I have explained. No? Multi-threaded program means we are having only one program, but that program is divided into separate independent parts. Each independent, okay, part is nothing but a thread. So here if you take this concept, that is some product division, multiplication, and what is the other one? Subtraction. So here all these five tasks are independent or dependent. Okay, all these are independent only, because sum is different task, product is different task, like that all these five tasks are independent tasks. So whenever we have independent task, so take that as one part of the program. See, same program, they are not different programs. I am taking only one program. In that program I am creating 5 threads, one thread for each task. How do we create 5 tasks? Tell me, 5 threads. Same way, if you understand this, how do we create a thread? Then we can create 5 threads for each tasks, for each of the 5 tasks. So tell me, how do we create a thread for first task sum? I will write class my thread 1. 5 tasks, no? Here only one thread, no? Here I am creating 5 threads, no? That's why take class my thread 1 extends thread. Okay. After that public void run. Always we must override the run method of the thread class. Okay. Next, inside the run method, I will write the functionality for that sum. So how do we find the sum of 2 numbers or 3 numbers? Here write the functionality. That's why here always inside the overriding run method, write the functionality for that sum of 2 numbers or sum of 10 numbers, like that. So this thread, that is my thread 1, is for finding the sum of 2 numbers. So is it one thread? So inside this thread I am writing the functionality for finding sum of 2 numbers. In the same way, what is the next part? That is product. Next take the same like this, take one more thread. After this thread write the thread, that is class my thread 2 extends thread. Next, for public void run. So inside that run method write the functionality for calculation of product of 2 numbers. So here I am taking one more thread. First create my thread 1 for finding the sum of 2 numbers. Next, take one more thread, class my thread 2 extends thread. Again take the run method, overriding run method in the second thread also. Here write the, in the overriding run method, write the functionality of product of 2 numbers. Next, that is second thread. That thread is for finding the product of 2 numbers. Next, in the same way, take one more class. That is class my thread 3 extends thread. Then inside that public void run. So inside the overriding run method, write the functionality or job of that thread, that is for division of 2 numbers or division of 2 integers. So this is the third part. Okay. First part is my thread 1. So first part is my thread 1. Okay. This thread is for finding sum of 2 integers. Next, in the same way, class my thread 2 extends thread. Inside the overriding method, we have written functionality for finding the product of 2 numbers. So this is also part of the same program, and it is acting one more thread. So this is the second thread for me. Next, in the same way, class my thread 3 extends thread. Here I have written the functionality for this modulus of 2 numbers or division of 2 numbers. Okay, so this is the third thread for me. It is a part of the same program. Okay, next, like that, take one more class, that is class my thread 4 extends thread. Inside public void run method, write the functionality of that thread, that is for calculation of modulus of 2 numbers. So first sum of two numbers, then in the second thread product of two numbers, in the third thread division of two numbers, in the fourth thread find the modulus of two numbers. That is class mythread4 extends thread. Inside that public void run, write the product, write the division of two numbers. Okay. Next, in the same way, this is also part of the same program. Okay. Next, in the same way, last thread is class mythread5 extends thread. So inside that class definition, public void run. Inside that, write the functionality for calculation of subtraction of two integers. Like that, here I have created how many threads? 5 threads. Please complete this task to understand the multi-threaded programs. So take different tasks, means which should be independent tasks, which should not depend on each other. So all these 5 tasks are independent tasks. That's why I have taken separate thread for each task. So first thread is calculating sum of two integers. Second thread is calculating sum of the product of two integers. Third thread is calculating division of two integers. Fourth thread is calculating modulus of two integers, and fifth thread is calculating the difference of two numbers. Like that, I have created 5 threads. Okay, and each thread is doing a separate independent task. But all these threads are in the same program. That's why multi-threaded program is nothing but we are dividing the same program into multiple threads. Already explained in the definition clearly. What is the difference between process-based multitasking and thread-based multitasking? So executing several tasks. Here several tasks are our 5 arithmetic operators I am taking. Addition, division, multiplication, product and subtraction. So executing several tasks simultaneously, where each task is a separate independent part of the same program. Here we are writing only one program, that is multi-threaded program. Inside that I am taking 5 parts for performing 5 tasks. Inside each part I am performing one task. Several tasks, no, here I am performing 5 tasks. So each that is independent part of the same program. So each task is a separate independent part of the same program. So such a type of multitasking is called a thread-based multitasking. So thread-based multitasking is nothing but multi-threading. Okay, multi-threading is nothing but thread-based multitasking. And each independent part is called a thread. So, and this is very, very important. And each independent part is called a thread. See, here I have explained the 5 tasks with this program. No? So here class my thread 1. So this thread is performing addition of the functionality of our addition of 2 numbers. So this is one part. Next, after that I am writing class my thread 2. That is doing product of 2 numbers. That is part 2. Okay. So next, my thread 3, my thread 4, my thread 5. So here I have created 5 threads for performing 5 tasks. Means each thread is performing one task. Now all these are parts of the same program, not a different program, remember. So we are writing only one program. Inside the same program, I have created 5 threads. Okay, like my thread 1, my thread 2, my thread 3, my thread 4, my thread 5. So I am creating 5 separate independent parts, and each separate independent part is nothing but a thread. So this is part of the same program. That's why it is called independent part of the program. It is called a thread. Like that, here in the same program, I have created 5 threads to perform 5 tasks, that is addition, multiplication, division, modulus and subtraction. So all these are parts of the same program, and each individual part is nothing but a thread. So like that, in the same program I have created 5 threads, okay, for performing 5 tasks. After that, how do we complete that program is same class. After writing the 5 threads, means 5 classes with my class names, my thread 1, my thread 2, my thread 3, my thread 4 and my thread 5. Next, finally, you write this class. So inside this class, write the main method. Okay. See, this is one more thread. So in this program, I have 6 threads. What are the 6 threads? My thread 1, my thread 2, my thread 3, my thread 4, my thread 5, and main thread. So in this program, I have 6 threads. Okay. Main is also one thread. Next, how do we create objects and how do we invoke? Tell me. I have to invoke all the threads, no, to do that specific functionality. Addition is one functionality, division is one functionality. So for each task, I have created 5 threads now. After that, I have to invoke the overriding run method of that thread to do that functionality. So overriding run method is very, very important inside each thread. Now, how do I invoke the overriding run method of each and every thread is, now I will write like this. So my thread 1, name of the class is, first one is my thread 1, no? So my thread 1, T1 is equal to new my thread 1. Okay, this is the object creation for the first class, that is my thread 1. After that, my thread 1, T1 I will take here, okay. My thread 1, T1 is equal to new my thread 1. Then write T1 dot start. T1 dot start will invoke the overriding run method of the my thread 1 class. And that will do the functionality for doing or for finding the sum of 2 integers. That's it. Okay. So write 2 statements to find the sum of 2 integers which is there in the first thread. How do we write 2 statements? My thread 1, T1 is equal to new my thread 1. Next, T1 dot start. So through the start method of the thread class, our thread is registered with the thread scheduler, as well as from the start method of the run method, we are invoking our overriding run method of the my thread 1 class. Okay. So these 2 statements are for the invoking first thread, which will calculate the sum of 2 integers. Like that, take the second thread. That is my thread 2. Second thread class name is my thread 2. So my thread 2, T2 is equal to new my thread 2. In the same way, right? Then T2 dot start. On the second thread, we are invoking the start method. Okay, through start method of the thread class, our second thread is also registered with the thread scheduler. And it will invoke the overriding run method of the second thread, which will calculate product of 2 numbers. So how do we invoke the overriding method of the second thread is by creating same 2 statements enough. My thread 2, T2 is equal to new my thread 2, then T2 dot start. So this is the second thread invocation. Next, third thread, which is performing division of 2 numbers. That is my thread 3, T3 is equal to, take different reference variable names. Don't take the same reference variable. So my thread 3, T3 is equal to new my thread 3. Then T3 dot start means this thread is also registered with the thread scheduler, and it will invoke the overriding run method of the my thread 3 class, which will calculate division of 2 numbers. Okay, next. How do we invoke the fourth thread? Again, create the object. Only these 2 statements are must for each and every thread. Okay. Now write fourth thread. My thread 4, T4 is equal to new my thread 4. Then T4 dot start. Then through the start method of the thread class, our fourth thread is registered with the thread scheduler, and also the overriding method of the my thread 4 class will be invoked to calculate division of modulus of 2 integers. Next, last one. Okay, like that for each thread we should write 2 statements. Here we have created 5 threads. That's why totally we have to write 10 statements. For each thread, 2 statements like this. That's it. How do we write the last 9th statement for the last thread? My thread 5, T5 is equal to new my thread 5. Then T5 dot start. That's it. That is the 5th thread. Like that. Like here I have created only 1 thread in addition to the main thread. That's why I have written only 2 statements. If you create 5 threads, so for each thread we have to write 2 statements. Like that, if you create 5 threads totally, like this, we have to write 10 statements. For each thread, First create object, after that invoke start method. Like that, for each thread we have to write 2 statements with different reference variables. And then all the 5 threads are in the waiting queue. Then the thread scheduler, which thread is assigned CPU by the thread scheduler, nobody knows. That's why we can't expect the output even though if you write the 5 threads. Next here, if you want to write the main method functionality, after the 10 statements, you can write the main method functionality. That's it. So this is the best example for multi-threaded program. This program is only for, here we have written the functionality of thread is only for using for loop we have written now. This is to understand the concept only. If you want to write the full program on multi-threading, take this. Yeah, if you want to take 3 arithmetic operators, take 3 enough. No need to take 5. Okay, if you want to calculate sum, okay, product and division of 2 integers, then take only 2. Like that, we can write the multi-threading programs. So finally, we must override the run method of the thread class and don't override the start method of the thread class. So with these 2 important points, you can study all these, you can read all these cases on your own. Now, if you study all these cases, then only you can get the full knowledge. See, if the interview question is, can we overload the run method of the thread class? Yes or no? Yes. We can overload the run method of the thread class. But when you overload the run method of the thread class, this is like normal function call. But this function call is, it is automatic. Inside the start method of the thread class, this run method is invoked automatically. Only inside the run method with no parameters only, we will write the functionality of that particular thread. Here you can write anything, but this function has to be invoked explicitly. Like that, if you understand. So if we are not overriding the run method, what will happen? Read this one. Next one is, if you are overriding start method, don't override the start method of the thread class now. Suppose if you override the start method of the thread class, what will happen? I have explained here. Then, see, it is never recommended to override the start method. 2 important rules are, don't override the start method of the thread class, and we must override the run method of the thread class. These 2 are very, very important. So if you understand these, you can read all these cases on your own. Next class, I will explain life cycle of the thread, and also how do we create a new thread, or how do we define a new thread using runnable interface. Okay. Next class, I will explain this. This is also important, life cycle of thread.